All right, hello everybody. Welcome to our next video. This is going to be a very short and sweet video for a couple of reasons. So let's get into it. We're going to be talking about Bohr models and valence electrons. So the reason that this is going to be a little bit shorter than maybe another video is because this first learning objective is normally something that we would do a lot in class, but given the fact that we are doing things virtually, it's not very easy for us to do this type of thing online. So I'm just going to show you what it's about, but we're not actually going to need to do the actual work behind it. So that's why this video is going to be a little bit shorter than maybe it could have been. The first objective here is for you to be able to construct Bohr models of atoms based on their electron configurations. We've learned how to do electron configurations, and what you can do is you can make these things called Bohr models using electron configurations. I'm going to show you how to do that in just a second, but we're not going to have any sort of assignments or activities based on that due to us being in virtual school. The second objective for today, and this is what we are going to do, you will be able to define valence electrons and describe how the periodic table can be used to determine an element's number of valence electrons. Okay, so this is going to be sort of the main focus for today and what your assignment will be about. Okay, so a Bohr model, like I said, is a diagram of an atom which shows the placement of the electrons inside the atom. The electrons can be found in concentric rings, which represent the energy levels of the atom. And using an element's electron configuration, you can construct a Bohr model. So here's how it works. Like I said, I'm not going to need you to do this. We would do this in class if it was, like regular school. But since we're not in school, I don't want you guys to have to do a bunch of drawing and stuff at home. I don't want to make your life any more complicated than it already is. So I'm just going to show you how this works, and then we'll move on. So this is an element called sodium. It's number 11 on the periodic table. It has 11 electrons. This would be the electron configuration for sodium. And then this is what the Bohr model for sodium would look like. The way that it works is you look at the numbers out front of each orbital, so like 1, 2, 2, and 3, and you add up these electrons in each ring or in each energy level, right? So this 1 right here is for the first energy level. These 2s are for the second energy level, and this 3 is for the third energy level. You add up the number of electrons in each energy level, and you put them on the corresponding ring. So 1s2, that means there's 2 electrons in the first energy level. That's why I have these 2 electrons here. 2s2 and 2p6, those both start with a 2. So these orbitals are both in the second energy level, and there are 2 plus 6 electrons there for a total of 8. And so that's why I have 8 electrons that are circled in green on the second ring, in the second energy level. And then there's just 1 electron in the 3s orbital, right? 3s1. So that's why there's 1 electron on the third ring circled up here in purple. So that's how Bohr models work. Okay, and like I said, we would normally do this in class, but we're not going to do it in virtual learning. What I have here is a periodic table of Bohr models that have all of the electrons filled in already. Okay, all I want to show you here is that there are some similarities between some of these models. Okay, as you go from left to right, you can see the electrons that are in red. Those are the ones on the outer ring. It goes up by 1, right? So from lithium, there's 1. For beryllium, there's 2. For boron, there's 3. I'm counting the red dots, right? The red dots. Those are these outer electrons. So it goes 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then after 8, if you try to add another electron, then it goes into the next ring up. Okay? And so you start over again at 1, 2, 3. What this shows us is that there's actually a pattern that we can use. Elements that are in the same column on the periodic table have the same number of electrons in their outermost energy level, or in their outermost ring. okay? And that's true no matter where you look, okay? If you look at elements in the same column, they have the same number of electrons in the outermost ring, right? So if I look here at carbon, silicon, and germanium, carbon has 4 red dots on the outside, silicon has 4, and so does germanium. If I look at fluorine, chlorine, and bromine, fluorine has 7, chlorine has 7, bromine has 7. Once again, I'm looking at those red electrons on the outside, right? That is what's common amongst these. The only exception to this rule is with helium and the others. Okay, so helium only has 2 because it's a small element. It only has 2 electrons in its outermost ring, whereas neon, argon, and krypton all have 8. Okay, so that is the only exception to this rule. So what are those electrons called? Okay, well, those electrons are called valence electrons. Okay, and this is a keyword, a vocab word that you're going to want to remember. Okay, valence electrons are electrons in the outermost energy level, or the outer ring of atoms. So I may be showing you some pictures like this. Okay, and so I need you to know that these electrons on the outside are called valence electrons. Okay, and they are in the outermost energy level of an atom. Okay? These outermost electrons determine properties of the elements. Okay? We can use, because of that pattern we just sort of talked about, right? We can use the periodic table to easily determine the number of valence electrons in an element. Okay? It's just equal to the group or column number if you exclude the transition metals. Here's what I'm talking about. Okay? It doesn't work, this pattern doesn't work for these elements down here. Okay, so the transition metals, they kind of break the rules, and so the pattern that we're going to talk about today doesn't apply to these. But if you're only talking about these elements over here on the left side, or these elements over here on the right side, you can use this nice little rule to determine the number of valence electrons in an element. Okay, all of these are going to have 1 electron on the outside, right? And if I go back and show you, right? Hydrogen, lithium, sodium, potassium. These guys all have 1 electron on the outside, 1 valence electron. These are all going to have 2. These are all going to have 3. These are all going to have 4. That was carbon, silicon, and germanium, right? You can see that they have 4 red dots on the outside. And then 5, 6, 7, and 8, right? And remember, the only exception to that rule is this element right here, which is helium. Helium only has 2 total electrons, so it kind of is the only thing that breaks that rule. Okay? All right, so you guys are going to have a short Canvas quiz to work on for me that's going to ask you some questions about valence electrons, and you're going to want to use this table here to help you to answer most of those questions. Okay? All right, thanks a lot for watching, and I'll see you after the video.